Good evening, good evening, everyone. Uh, today I am going to give you a start introduction to antennas and their basic types. The antenna is a device that attacks some or interface between electromagnetic waves traveling through space and electrical current in a metal conductor. In simple words, uh, the antenna converts electrical energy into electromagnetic waves for transmission and converts electromagnetic wave back into electrical signal during reception. The antennas are widely used in radio, television, mobile communication, Wi-Fi, satellite communication, radar, and many other wireless systems. Size of an antenna depend on its application and operating frequency. Some common antenna shapes are shown in this diagram. Um, First type is an square antenna. It has a square-shaped radiating area. Second is the rectangular antenna, which has a rectangular shape and is commonly used in different antenna design. Third type is the dipole antenna. It is one of the simplest and most important type of antenna. It normally consists of two conducting elements and is widely used for radio communication. Fourth is the circular antenna, which has an oval electrical shape. We also have triangular antennas, disc antenna, circular ring antenna, circular ring antennas, and ring sector antennas. These different shapes can provide different electrical characteristics and radiation properties. The most important point to remember is that an antenna is used both for transmitting and receiving electrical energy. During transmission, the electrical signals are converted into electromagnetic waves. During reception, electromagnetic waves are converted back into electrical signal. So antennas are one of the fundamental components of modern wireless communication. 1 minute, I will share more content. Next, I will discuss about antenna frequency. One of the most important concept in antenna design is frequency. Frequency tells us how many cycles an electromagnetic wave completes in 1 second. Again, repeat. Frequency tells us how many cycles an electromagnetic wave completes in 1 second. It is measured in hertz. Different communication systems operate at different frequencies. For example, radio, television, mobile communication, Wi-Fi, radar, and satellite systems use different frequency bands. The antenna must be designed according to the frequency at which it operates. If the antenna dimensions are not suitable for the operating frequency, it is performance may be reduced. We, we have discussed about wavelength. Another important concept is wavelength. Wavelength is the distance between two corresponding points of a wave, such as two consecutive peaks. The relationship between frequency and wavelength, the lambda equal to c by f. The lambda equal to c by f. Okay. Here lambda represent wave, c represent speed of light, f represent frequency. These relationships tell us that when frequency increases, wavelength decreases because antenna dimensions are related to wavelength. Higher frequency antennas can often be made smaller. Higher frequency antennas can often be made smaller. This concept again repeat. Lambda represent wavelength, c represent the speed of light, f represents frequency. This relationship tell us that when frequency increases, wavelength decreases because antenna dimensions are related to wavelength. Higher frequency antennas can often be made smaller. Higher frequency antenna o- can often be made smaller. Resonance. Resonance is an important concept in antennas. An antenna can operate efficiently when its physical dimensions are suitable for the wavelength of the signal. At or near its resonant frequencies, the antenna can transfer energy effectively between the electrical circuit and the electromagnetic field. For example, a simple dipole antenna is commonly designed with a length related to a fraction of the operating wavelength. Next, we have discussed about antenna impedance. Another important parameter is the antenna impedance. Impedance refers impedance represents the opposition that the antenna presents to the flow of alternating current. For efficient power transfer, the antenna impedance should be properly matched with the transmission line and the transmitter or receiver. If there is a mismatch, some of the transmitter power can be reflected back toward the source. Next, we have discussed about bandwidth. Bandwidth is the range of frequency over which an antenna operates satisfactorily. Some antennas are designed to operate over a narrow frequency range. Some antennas are designed to operate over a narrow frequency range. Um, Wide frequency range example torch light. Narrow frequency range example laser light. Will other can work over a much wider range. For example, on antenna designed for a channel. Specific communication channel may have relatively narrow bandwidth, while broadband antennas can operate over a large frequency range. Bandwidth is especially important in modern communication systems because many systems need to handle the multiple frequencies or high data rates. Polarizations uh, describe the describe the orientations of the electrical field of one EM wave. The common type include linear polarization, circular polarization, elliptical polarization. The linear polarization can be further described as vertical or horizontal for good communication. The transmitting and receiving antennas should generally have compatible polarization. Incorrect polarization alignment can reduce the received signal. Antenna directivity. Wait. I will discuss about antenna directivity. And directivity describes the how strengthly on antenna uh, concentrates concentrates radiation in a particular direction. A highly directional antenna focus more of its radiation in specific direction. For example, antennas used for satellite communication or point-to-point communication often need uh, high directivity. On the other hand, some applications require signal in many directions. So on omnidirectional antenna may be more suitable. Next, we have discussed about antenna efficiency. Antenna efficiency indicates how effectively the antenna converts input electrical energy, input electrical power into, uh, again repeat, antenna converts input electrical power into radiated electromagnetic power. Not all of the supplied power is necessarily radiated. Some power can be lost because of conductor resistance, dielectric losses, and other effects. Therefore, the put antenna should have high effectively uh, for uh, for its intended applications. Next, we have discussed about near field and far field. The phase surrounding the phase surrounding on antennas can be broadly divided into different regions. The near field regions is closer to the antenna. In this region, the electromagnetic fields have characteristics that are strongly influenced, influenced by the antenna structures. Further away is the um, far field region. How here the electromagnetic waves behaves more like a freely propagating wave, and the electric and magnetic field have a suitable relationship. The far field radiation pattern is particularly important when evaluating how one antenna radiating energy. Next, we have discussed about antenna array. Sometimes a single antenna element is not enough to obtain the required performance. In that situation, several antenna elements can be combined to form one antenna array. By controlling the phasing and phase of the element, engineers can control the directions and shape of the radiation pattern. Engineers can control the directions and shape of the radiation pattern. Direction and shape of the radiation pattern. The antenna arrays are widely used in radar, satellite communication, mobile networks, and modern wireless system. Next, we have discussed about transmitting and receiving antenna. There are two common ways to describe antennas use: transmitting antennas and receiving antennas. Transmitting antenna receives the uh, electrical power from a transmitter and radiates electromagnetic energy. A receiving antenna captures the electromagnetic energy from space and produces an electrical signal for the receivers. Um, Many antennas can be used for both transmission and receptions depending on the systems. Next, we have discussed about antennas in everyday life. We can find antennas almost everywhere in modern technology. A mobile phone contains antennas for cellular communication, Wi-Fi, Bluetooth, sometimes other wireless functions. A Wi-Fi routers uses antennas to communicate with phones, computer, televisions, and other devices. Television and radio stations use antennas to transmit signal over a large areas. GPS systems use antennas to receive signal from satellite. See, GPS systems use antennas. GPS system use antennas to receive signal from satellite. Uh, this point is very important. So again repeated. GPS systems use antennas to receive signal from satellite. Radar system use antennas. GPS system use antennas. Radar system use antennas, but different. GPS system antennas to receive signal from satellite. Radar system antenna to transmit and receive a radio frequency electromagnetic waves to detect object and determine their position. Next, we have discussed about factors to consider when selecting an antenna. When selecting an antenna for a particular applications, engineers consider several factors. The most important factor include operating frequency, required bandwidth, antenna gain, radiation pattern, polarization, physical size, efficiency, impedance, installation environment, required communication range. The antenna should be selected according to the requirement of the communication system. Next, we have discussed about uh, simple real life example. Let us take a simple example of a Wi-Fi router. When we send information from our mobile phone through Wi-Fi, the information is converted into an electrical signal and produced by the wireless circuit. The root the router antenna radiates the corresponding electromagnetic signal into space. The mobile phone antenna receives these electromagnetic waves and convert it back into an electrical signal. The phone then processes this signal and recovers the information. This entire process happen extremely quickly, allowing us to browse the internet, make video calls, stream videos, and transfer files wirelessly. This video, okay. Thank you for watching this presentation. Thank you so much.